So, good afternoon, everyone. And my name is Yorgos Gadanakis. I'm an assistant professor at the Cyprus University of Technology. And together with Andrea Zitek and Orsos Guido Orsos, we are organizing this special interest group of the ICA EDU. And we are organizing this webinar on generative artificial intelligence for sustainable entrepreneurship. We are excited to have you join us for what is promised to be an engaging and a very insightful discussion on how generative artificial intelligence is reshaping innovation, creativity, and business development, particularly for entrepreneurs focused on sustainability. Of course, we all know that the world and most industries are increasingly turning into the use of artificial intelligence in order to solve complex challenges. So today, what we are going to do is we will explore how this powerful technology is helping businesses to design smarter, more efficient, more sustainable solutions, and also to create resource-efficient products in order to optimize supply chains and to enhance communication with stakeholders. We have three excellent speakers today that will share how artificial intelligence is transforming the future of sustainable ventures. So what we aim to do at the end of this session is not only to inspire fresh ideas, but also to highlight the real-world applications with a presentation of some case studies and how generative artificial intelligence is fostering sustainable business models. So we have an exciting lineup. I will simply introduce the names and the affiliation, and I will give some space for the speakers to present themselves and their expertise. So in the order of presenting, we've got Raffaella Bernardi, who is an associate professor at the Faculty of Engineering at the Free University of Bolzano in Italy. We've got Francesco Ravazzolo, who's a full professor of econometrics at the Faculty of Economics and Management at the same university as Raffaella at the Free University of Bolzano in Italy. And we also have Giorgio Zaparella, who is a senior pre-sales Internet of Things engineer at the CIRIC Internet of Things company based in Cyprus. Now, following the presentations, we will have a panel discussion and we will conclude with some reflections and comments on how generative artificial intelligence can support sustainable entrepreneurship in the future. Guido will be managing the Q&A session on the background, so please post all questions there. We won't address any questions during the presentations. We will let the speakers present, and then we will follow up in terms of a panel discussion with your questions and their answers on the topics. So let's get started, and let me invite Raffaella in the panel. So Raffaella, if you could please share your screen. Yep, and if you make it to presenter mode, excellent. So thank you very much, Raffaella, and welcome, and thank you for accepting this invitation, and the floor is yours.
Okay, hi, hello everybody. I've been tasked to introduce large language models, which is indeed part of my expertise, of my research line. And I have to speak about it within the framework of this webinar. So this is for me an important challenge that I was glad to accept, and so thanks for the invitation. And to do that, I thought to start by giving the history a bit of how we reach generative AI from our field, natural language processing. So I've been, in the last 20 years or so, I've been coordinating masters on natural language processing. In the beginning, when I started here at the Free University of Bolzano in 2002, I was using these slides from a European project because it was giving the vision of where NLP was going to. And back then it was really a dream. But the idea was to have an AI assistant able to let two speaker speaking at the phone their own language, German and American. And the AI system was meant to be able to transcribe speech into a text and then translate it into the other language, and so passing that information to the other interlocutor so that the two people could understand each other. And at the end of the conversation, there was even the vision of making the summary of the dialogue. That back then, this was really kind of a dream, and people didn't believe it was going to happen. But we see that, I mean, year after is where we are, I mean, what we get. But this is what I was using, and I was far away from people to believe that no, that was a realistic goal. Then with the years, explaining what NLP is became easier, because when then I moved to the University of Trento in 2011 or so, I was start using Google, which was kind of start to be a realistic something to catch, something to understand. I was giving this translation that everybody then was using, so it was easier for people to understand what they were going to study working with us. Then the task became even easier because I started using Alexa. Amazon Alexa, and so to explain also the challenge that are behind having a conversation with an AI assistant, because we are all kind of experience some funny facts with the conversation that we can have with Alexa when it doesn't understand what we say or whatever. And interestingly, the people to whom I was speaking when presenting the Vermobile project, some of them actually are now senior research at Amazon Alexa, and so they kind of made their way. Speaking of how the task of presenting what NLP is has become easier, then I was also then with the time start introducing this screenshot to explain that actually NLP can also be combined with computer vision, which in fact is the kind of thing I've been working on for 10 years or so, combining having system that can speak, can be kind of verbal-like, but they speak about the things they see. So combining computer vision and NLP. This has been my work for a while. Anyway, so the way in which I was then summarizing all these goals or these activities was with this slide, which conveying the overall message, which our goal, the NLP goal, since ever, has been to develop a model, a software that can let the computer to process natural language input, to understand, encode natural language input, and generate natural language output. Now, from NLP, now the term that you hear and that is in the title of the webinar is generative AI. So the important steps that have been that have happened through the years, from the 50s when all this started till now, is the introduction of the internet, in the sense of having lots of data. We were calling it the web as a corpus, lots of data that can be used to train a system to learn the language, to learn natural language, to learn to process natural language, and to generate natural language. Then the other important milestone in the field has been the demonstration that neural networks, which were already present, the idea of which was present in the 50s, this neural network can in fact are able to learn from lots of data, and even more, they can do so if run on a big computer, big server, if they are given lots of computational power. So from the rule-based system that we had in the beginning in the 50s, we are now in the deep learning era, and the new models, with the new neural network models we use, they're called transformer. So now I'm going to explain a bit about these deep learning and transformer models. So we, as I said, like neural networks, they've been there for a while, but what then in the 2012, in the computer vision community, it was shown that if you take a big neural network, a network with lots of layers, and you train them with big data, on a task, on a classification task, you train the model to recognize, to classify, to say what is the object in the image through these several layers that indicate the deepness of the network. Then you obtain vector representation that represent the object, so that then a classifier can indeed properly say that there is a dog there. So the model takes the input and encodes the information, producing a vector out of which something then can be output. Similarly, in NLP, in our community, we were working with vectors to represent the meaning of words, with the idea that vectors which are close to each other represent similar words, and words that are vectors that are far away represent other dissimilar, distant, meaning-wise words. Now, Mikolov, in 2012, in his PhD thesis, showed that you can obtain this vector representation of words by using a neural network. He was using a simple one with just 3 layers trained to predict a missing word. So something like, if I take this sentence, ICA, Association for European Life Science University, is a network of more than 15 universities from the EU and neighboring, and the model has to predict countries. And by doing so, the model was able to learn the correct vector representation of the words. So all these ideas, neural network, the idea of words which are similar encode a similar meaning, and the idea of learning to predict the next token, they were all there in the 50s, but throughout these years, now recently, I mean in the last 10 years or so, they became effective and have been shown to be useful to work. And these next word prediction models were called language models. Then the next important step has been that if you have this vector representation, Google showed in 2014 that you can also then decode, generate. So we have processing, natural language understanding, natural language input, and generation, decoding. For instance, the machine translation, the Vermobile kind of thing, mission can be achieved by having a system that left to right incrementally builds the vector representation of the input sentence, vado in spiaggia, and then once it has built the vector of the full sentence, it can start decoding, always predicting what is the next word that comes after, and so on. Then it produces the translation. Similarly, this can be done multimodally, because if, again, now I have an image that is encoded with a vector, I can apply the same method and start decoding it, producing in natural language the description of the image, or I could do the vice versa. I can encode a sentence, vado in spiaggia, and then decode, generate the image that represents the meaning. So in this sequence-to-sequence architecture, encoder-decoder architecture, tokens are processed incrementally left to right. The transformer instead made the change of processing the various tokens in parallel, and moreover, exploiting the attention mechanisms, saying what are able to say where to put attention, which weights to increase, which tokens play a major role for the representation that they have to build. So all these brought from the language models that we were familiar with since the 50s in a way, and then with Mikolov became popular for the way in which he used them, we moved to large language models, where the large comes from the fact that these neural networks are not just few layers, not a few neurons, but they have many parameters. And then of these large language models, we have different degrees of size from the small to the very large. They can be just been trained with next word prediction, or what then has been shown that they increase the performance if they are fine-tuned, they are tuned to execute some instruction, and even more if they are then trained to chat with the users and learn from the feedback they receive from users. We have private ones and public ones. And all these kind of, like now there is a boom of all these various models at disposals. What is interesting to comment, to observe, I think, is also, so there is clearly a huge increase on the size of these models, which corresponds to an increase in what they consume, in the pollution they create, and also in the energy that they use for being run and for being trained and so on. And these were already the data of 2019, so well before ChatGPT. So there is now like clear call from even like I found this thinking of, while working on the webinar slides, the UNESCO report that call for smaller models because they can be smart and accurate if tailored for a specific task, and they are more accessible. And I also found interesting to see that Mikolov, the person who in 2012 brought this important boost to the use of neural network, has now funded this company, Bottle Cap AI, which has the mission of creating small models. So I was also asked to think about applications, and then I got really scared about it. I mean, I really don't know what to say. So I thought, okay, let's ask ChatGPT. It provided to me some kind of ideas, but well, if you read through them, they are very shallow, let's say. But then I thought, okay, I told him to whom I was going to speak. I kind of personalized the search, saying I'm going to speak to ICA people. And then it became more kind of fine-grained in the proposal. I even learned while chatting with him, or it, or whatever you want to call it, that there is already some work on the multimodal part on vision and language, AgriBench, which is a benchmark, a data set. And in fact, it exists. I even found a paper. So this to say, yeah, okay, these are possible ideas, but I think that what is needed for really thinking about the application is synergy between the people who kind of know about these systems, how they can work, and the people of the society that then are there as an expert and have the needs, and they can explain what they need to improve their life, their quality of their work, and so on. What I can share, though, I think, is this platform, which I find interesting and hope that can be useful for you, where you can find data sets, models at disposal, as well as a list of possible tasks of NLP, tasks that we work on, so things that these models can do, as well as the multimodal one, like audio, text, vision, language, document retrieval, and also a leaderboard where you find all the models, how they perform for even like specific tasks, and also the list, the number of how much they cost in terms of CO2. Now, what next in NLP? We are working on challenges for creating these smaller models. For instance, there is this Baby LM challenge, and the one we are working on to organize, like here where we are calling the community to train models to learn from dialogue games, like turning through interaction as children do. There is the challenge on multimodal, so to go beyond language and vision to also audio and to also 3D, to virtual environment. That's also an interesting line we are working on, embodied AI. And finally, I also want to put the attention on careful evaluation. So now I do some propaganda of our work that has recently been accepted at MNLP, where we show the importance of using fine-grained, complete framework for evaluating these models that go beyond the leaderboard table that I actually showed before, and are more like really going into the method, the models to understand their ability. Finally, so why so far AI has been kind of the putting together an interdisciplinary kind of approach, but putting together disciplines with the hope of creating this model like AI, machine learning, neuroscience, logic, whatever, NLP. Now that we have this system, I think the important part is really on the connection with the society, thinking with the various stakeholders, the various expertise, how this AI can work with when improving to improve our society. And this is what for which for doing this we need to work together. That's all from my side.
Excellent. Thank you very much, Raffaella. Very informative. So I would like to invite the next speaker,
No,
Francesco, to share.
Let me first start thanking Andres, Guido, and Georgios for organizing first the seminar this webinar, and also for inviting me to present here. I spend 1 second, I do auto promotion at the beginning. This is who I am, so you can find the website with my name and so on. Indeed, I'm professor of econometrics. We'll come back later why econometrics is interest to this topic in Bolzano, and I also lead the Department of Data Science and Analytics, this in Oslo. But probably the most intriguing for today, I also very interested and experimented a few times with firms and startups, the topic of technological transfer. Voila. And this is what I want to present today, stairs. So I go from what our Raffaella finished, and I see one possible way how you can apply AI for business or entrepreneurship, which was one of the first things that ChatGPT suggested. STARS is called Sustainable Tools Artificial Intelligence for Risk Solution. And I thought I could start with this and explain how we went there, because I think it's part of our education and so on. At the beginning, the origin is quite long, it's 20 years ago, 15, 20 years ago. And in particular, my partner, what he did, he built an association of academics and business people with different interests that try to model business risks. And the idea was to create a solution and methodology to handle all the possible risks that you have inside one firm. It can be small, it can be large. Pretty much soon, before so that, for example, NLP or AI became more and more standard, we realized, or they realized, I was not yet involved, that you need a platform to take control about that. And they developed what was called 4 pillars. That is an initial possible AI to push on the direction of business risks. So what they were doing, you will see later on, it was trying to collect information of a specific firm and connect it to general definition of risks. For example, one that maybe in Europe we are famous, we have huge and quite restrictive laws on GDPR. What does it mean for a firm? Now that is there is quite some debate at the moment around the European Union how we should advance about that. What we have done more recently is basically try to understand if the idea of combining academics and business, the idea to use a platform can be scaled up and can take benefit of the most advanced methods such as AI, specifically in this example, we will use a lot of NLP that Rafael has just suggested. I want to stress one element. We still believe that HI, human intelligence, is superior to AI, is over AI. We ask to AI what to do. But Clearly, AI can help a lot to develop and to respond to questions that an expert working group has in mind, is trying to answer. It offers the right tools to answer the questions. So let me give in one slide. Try to be on the 10 minutes so we can gain some time for questions. So in black, you see what the original 4 pillars is. And in red is where I want to spend more time because it's the easiest way, in my view, to present the contribution of generative AI. So 4 pillars are the 4 main areas that it was controlling for risk in a firm. If you want, is an advanced auditing tool where you check what can go wrong in your own business. Typical things at the moment are what? Legal, and that's the most important. If you hire people in a wrong contract and you don't, as examples, and you don't treat them correctly, of course, there are fees. Eventually, here the AI can help a lot because you can go in the constitution of a given country and more or less find immediately how much will be the fee. So it's a relatively easy task to do for a machine. For a computer, it's not the constitution, it's obviously the sentence of the justice. Sorry that I was not wrong, but you can find more or less what the risk can be. International legal risk is the extension about that because if the firm is dealing with different countries, there is also this component. Management of system is another example, which is pretty good because you can have, I believe with the COVID, later on we realized that firms are fully integrated with different operating systems, different parts in their own business models and making them communicating or having problem with communication or trading among them can be an important issue. ESG is another topic, sustainability and governance is another important element. What we decide to push on, and I will present in the next slide, is the geopolitical risk model, which focus explicitly on geopolitical risk. So why this? Why today I'm here? So we've developed country risks. So we want to know how risk is one country relative to another one. And they need to be divided clearly by country. But we also want that they are connected to concrete activities, in particular to the firm. So it's not only generic risks. So we know some countries can be or can create more problems than others. The problem is how much the firm is exposed to that. That's why it goes back to 4 pillars, which had always this type of address or direction. And this we believe is very important to understand the management of the firm. We need to use generative AI. Why? Because, as I will try to show in the next graph, we need to collect data, aggregate them, and interpret them. A human can do all of these kind of things. The question will be the time and the speed that he can do that. Clearly, I believe the human can ask this question, but the AI is the fastest tool to try to answer this element. We collect, so how do we work? What are the specific steps? So first of all, we build geopolitical risk indices. And how do? We use a large data set. We try to use all the information possible on the social and on official sources. So there needs to be a large, in general is an LP, a language model, that is searching for information about one firm or another one. Newspapers, as I said, Google searches, but also official statistics are the important sources about that. How do we classify them? Because, we need to select the information and tell what the AI should look for. We decide to follow the World Bank classification, so we use the World Bank topics, and the most important are economic conditions and macroeconomic vulnerability and debt. This is our what we are building. There are another one which is quite important, that is the political risks about one country, but the definition is slightly more difficult in my view to give. So when we have this definition in mind, we run the NLP that is finding for each country in the data set this possible source of information. And then there are some way of aggregating them. The easiest and the simple to explain to you is by basically counting how many times in a given day some words are used. With the idea, if we talk more about one topic, probably there is more interest, possible more risk, towards this type of argument. There are also other ways to deal with. We can discuss individually if you like. In general, we believe that it's better to build these indices with large institutions for a problem that Raffaella was mentioning, that they can be consuming and they can require quite some computing power. But we also believe following on our approach, then later on, a smaller local AI model will function very well. So the idea, first we build these indices or by picking from international institutions. So personally, I'm working with the European Commission, and so we are trying to build with them. They will make available to everyone. Where our tool is coming in is with the second step of the AI, that what it does, not only develops, but is able to put in, as you will see later on, in a figure, in a map, so indicating what is happening, and eventually is also able to comment on them. So you can see what's the difference between yesterday and today in terms of the general, first the risks, and then if you really want, this needs to be done locally, much more locally, the exposure of firm A to this type of issues. So eventually you can learn in general how a country is doing, a second, how much firm I is exposed to this type of oscillations in the economy of the country. We build what is nice, that it is a bit of time that macroeconomists and econometricians as me are working on this type of indices, but the frequency was always the problem. So they were monthly or for all US daily. So what you can do now is jump in much higher frequencies such as daily. Just a very simple point. We more or less, all of us are able to speak English. Other languages, and newspaper will be in other languages, clearly is much bigger issue. And when you move in small countries, this is even a larger issue. That's what AI can do. It can easily translate from one language to the language that you require to work with. Of course, it will be an approximation, that I know, but still will be better than nothing. So this is the output, for example, in terms of indices, and then this goes inside the specific firm. So I took the map with more or less 40 countries in the example here, and red means bad, blue means good. We took a couple of weeks before the Russian invasion of Ukraine, and 1 week after. So we decided to work with weekly reference. You can really see how the color has changed across them. I'm not interpreting now. We can discuss again about that. I will clearly US, Russia, and Europe became much more red about that. Other countries had a lower effect on that element. Whether it's correct or not, this is not the scope. We are writing also papers, and there are explanations about that. The next step, which I don't have here because I don't want to expose any of my firm involved on this, is clearly taking, if you have, I don't know, a plant in Australia, what will be the effect with this firm, which is located maybe in Canada, just to give you an idea. And that's what we will do. So what we have done up to now, and then, sorry, I try to stay 11 minutes now, I'm sorry about that. So as I mentioned, we are building country index. Previously, there were long-term updates, and they were strongly subjective element. So what we thought, okay, we need to move, first of all, to be faster in updating. Second, so daily. Second, we should try to be a bit less subjective, meaning we will always be subjective, but we can give AI rules to try to learn and explaining, at least people can comment about that. We jump on sentimental analysis. Is how we do this one, how it's called in our research type of approach. As I mentioned, we are completely research driven. We have written books, papers, and what we hope is integrating this research agenda in business activities. Thank you.
Excellent. Thank you very much, Francesco, and thank you for trying to keep the time as well. Okay, so I've posted on the chat. Please either use the Q&A to post your questions, comments for the two speakers, and we are going now for the third one. So Yorgo, when you are ready, please share your screen, and then we will come back with the panel discussion. So Yorgo, the floor is yours. Excellent.
Yeah, thank you very much, Yorgo. I hope you can see my screen now.
Yeah, it's fine. Absolutely fine.
Good, thank you very much. So hello everyone from myself as well. So yeah, I want to thank firstly Yorgos, Andreas and Guido and the ICA group for inviting us. And it was very nice to hear also the other speakers speaking about their stuffs. So I'm here today representing Cyric IoT. As Yorgos said at the beginning, we are a company based in Cyprus and Greece, and we are solely doing commercial activities around Internet of Things. So I will try to give you a backbone of how we are getting that data, let's say, and then how we are now trying to use that data to create some more value out of it based on the feedback that we get from people on the ground, from customers, and try to incorporate AI models to enhance our service and also give a solution greater to people out in the market. Just as a side note, the mother company is Cyric, so it's doing European R&D and at national level. So the commercial department was coming out and born out of the main company, but my department is solely working on the commercial solutions. So yeah, my background, just briefly where I'm coming from, I have a background in computer science, and in general, I'm working on sensing solutions, IoT platforms, cloud integration, and data analytics. So then, yeah, as I was saying before, I'm here today for Cyric IoT, which is a technology solution provider, if you like, in the domain of the remote sensing, control, and automation. So we are not bounded by any technology and communication protocol. We just have experience mostly with a wireless protocol called LoRaWAN, which give us the advantage of wireless battery powered sensors, if you like, with long battery life, like 3 to 10 years, depending on the transmission frequency. There is cost efficiency there, low operation and maintenance cost, and of course, fast deployment. So as I was saying before, some metrics for the company. Okay, we are more than 8 years as a commercial department now in the market. We've deployed more than 200,000 sensors in the field, and also more than 800 gateways. So the elements for the LoRaWAN, just for everyone, is that we have a gateway, which is the router, if you like, of it, and then you have the IoT devices, the sensors, the end nodes, which they send data to a kind of a gateway, which is a smaller, is not like the tower that you see there, is much smaller, and then you get that data back to your IoT platform. And then some of the applications that I will try to give you today, some use cases from the field, so you get a feel of what we are working on and how basically Cyric IoT, because we are solely a hardware provider and integrator, but we did have some limitations. So after our learnings, then how we driving over with AI to expand our services. So cold chain monitoring, you can imagine refrigerators in a hotel, in a restaurant, in a trucking, delivering stuff around the globe. containers, pharmacy warehouses, and the list is going on. Now you have electricity monitoring, water monitoring. For instance, we are involved in a big project here in Cyprus, a public project where all the water meters are being replaced, and we have a smart water meters now where people do not need to go down there and manually write, let's say, the data. Everything is coming back to their databases online on a IoT platform. Smart buildings, smart retail analytics like supermarkets, buildings in a sense of the ESG, as Francesco, I think, was saying before as well. Smart irrigation, agriculture, farming, environment monitoring, and forest fire detection, which is a big topic for us as well here at the Mediterranean area. I will dive deep more into each of them. So basically what you see at the bottom here is some of the sensors that we're using. Then on top of it is some of our dashboards. And that's where I want to start with that, just to give you a context of what we are doing. As I was saying before, we are a system integrator. So we have vendors across the globe. We are working with them. They have a sensor. So then we have a third-party IoT platform. We have the experience. We make the installations. We set up the system. We go install it, take all that data back to the databases, and offer that as a service to the customer. Now, in terms of our experience and some limitations we found in the market, is that after we provide, let's say, that simple, which is not simple, but let's tag it as that solution to any customer, then we need to do some more customizations. One of them might be further analysis of that data, or more threshold alerts for the customer, etc. So by that meaning, 2 years ago, we started working on our in-house IoT platform, which then we can start building our artificial intelligence on top of it as a layer, which I will lead into that after I explain some of the use cases that we are working. So as I was saying before, this is an application where you can see all the refrigerator units, the temperature. Imagine that you are getting data every 10 minutes. You have your automatic reports where you can download. If something goes beyond the threshold, then you get an alert. Everything is automated for the customer. In a similar sense, you can get, let's say, the energy monitoring solution. So slightly different sensor. You get into the panel rather than having in a storage room and go and see what is written on a panel there. Then you have all that data back into your database, IoT platform, getting alerted, similarly to what I was saying before. Now, I'm going to give you an example here just to put it in a context. One of our clients here in Cyprus is a very big dairy producer, which, for instance, they had an issue. That's how they got in touch with us. Producing milk, halloumi, cheese, etc. All of them were getting energy from a different source of a panel. So they had a really big issue because the bill, it was costing way too much at the last, let's say, 3 months that they came over, and they had to pay it, and they didn't know the source of it. So after having such sensors installed at their premises, they could dig down and find that, okay, there is some kind of leakage in this producing milk area, so let's go down and fix that. Then on the other side, after they've done that, they can now be proactively know beforehand how much kilowatts they are burning, how much they are expecting that bill to be. So all sort of this stuff. I was saying before about a project for the water metering in Limassol. Now, also any of us, let's say, for instance, we had a hotel which they wanted to invest at their water meter, but basically, the solution, we are grabbing that data, and at this specific solution, we have also the capability to do it at the edge, meaning that we are collecting some samples, like sampling every 10 minutes, but then we are putting that data at the edge of the sensor, and then every once a day we're sending that package, because here at a scale, imagine that we are putting maybe hundreds of thousands of water meters for a city. So every package that we can send it afterwards, that means we save power and we save cost and all this sort of stuff. So yeah, some other solutions are smart buildings, if you like. So any smart light controller, like you can control your home by a button, by a smart scene panel. We have a power plug where people are connecting that plug into the mains plug, and if there is a cut of the power, they will get notified. So then you have the magnetic contact switch. You can imagine it on the doors, occupancy monitoring. So anything that you can imagine within a building in a way that you automate it. Here, the first running solution or customer that is using that for us is the occupancy sensor, where we have it in a malls or kiosk, and they want to have an artificial line at the entrance door, if you like, and measure how many people are going in and out. So they have a kind of a level of what's happening in the rooms there. Now, more recent, we do have more specific applications for the smart buildings. We can even measure how much soap you have inside, or how many people are in a toilet, not watching them. It's just a kind of a sensor, so not conflicting with any GDPR here, but it's just, I'm gonna give you another example from a real world environment. We had a contact with an airport, and you know, imagine now that how the cleaning is working is that, okay, every 5 hours I need to go and clean, let's say, the bathroom in an airport. But imagine that in these 5 hours, you don't know how many people have been in. There might be the case that you need to go in 2 hours, or there might be the case that you need to go in 6 hours. So by knowing how many people have passed by and used the bathroom, maybe that's a better service to give to the people. So we're working on that case as well. Smart retail analytics. Okay, you can imagine it.
Georgios, I really don't like to interrupt you, but we really should start then the Q&A. I'm not sure how many slides you have. Still,
I have 3 slides. I'm gonna run them quickly now. I'm finished.
Okay, that would be really great, because the people maybe have other obligations then, and so we have some questions. Thank you.
That's great. No worries. Thank you. Yeah, I've explained that for the toilets. Then I'm running to the final application and then wrapping up because we don't have time. So this is, you can imagine, this is a smart application for agriculture, where you have all your system trying to irrigate. So you have kind of soil moisture sensor, water pressure sensor, all connected to the water pump. And then you have that smart controller where, depending on how much moisture you have or temperature in the soil, you can automatically, from anywhere in the world, command it via a button, open the valve and stop, let's say afterwards, stop the irrigation. And then, okay, I'm passing that by. Smart parking is another one solution. Forest fire, as I was saying before, this is a project running in Ioannina in Greece, for instance, but there are multiple of them. So via putting sensors out in the field, you will be able to make a metrics and see when a fire has been detected. Now, my final slide, and I'm giving back to the team. So how we are trying to get, because we have a lot of data and a lot of applications. So as I was saying before, we've created our own IoT platform, and we try to integrate artificial intelligence on top of it. Now, we've started with 3 different elements, because these are the main priorities for us now. I'm starting from the second one, cold chain monitoring. So we have incorporating a machine learning model, basically, where we split all the refrigerator types, and then we can forecast the potential temperature drop or increase before it really happens. So that gives a value to the client, to what they would expect. Then the smart agriculture, we had a big issue here, because in order to give the threshold for an olive tree or for a citrus is kind of a difference. So we are trying to incorporate an LLM here on the platform, like acting as an AI agronomist, where they can give suggestions of what thresholds they would be liking to put on there. And then finally, and I'm closing with that, we are using it a lot for the support. So for instance, we have many requests from the customers because after putting a system out there, people might have technical questions or other. So we're building that to provide that online support automatically to the customers. So with that, thank you very much. And if there are any questions, I'm here to answer.
Thank you very much, Jorgo, and thank you very much, Francesco and Raffaella. Guido, I think you're monitoring the chat there.
Thank you. So first of all, I remind all of you to post your questions here or in the Q&A section of Zoom so we can post them. We have at the moment two questions. The first one is from Andreas and is mostly addressed to Francesco, but then I think also the others may have some, let's say, information to add on that. And is whether, let's say, first of all, the index that his startup is using to calculate the geopolitical risk is very interesting. But the question of Andreas is whether it can also be applied to, let's say, measure sustainability of country, and if you know any initiative that is trying to do that.
Thank you for that. So thank you first for liking the index, and second, going to that. So the biggest problem with the definition, I think the biggest problem is the definition of what is sustainable or what is sustainability. And that's what AI, I don't think it can do alone. So we should first agree on that. So for example, I was now Googling, so there is quite some work on corporate sustainability, which usually refers if the firms have enough finance or not. At the government, the easiest way is the debt. That's why we had vulnerability and debt, even if finally, maybe one of the last revolution or last changes in the last 1 year is that all the people are talking less about debt and they're talking about other things, or they're talking differently. I believe that in there is sustainable trading or trade, that's for sure, because that can also refer to the other question that how you account for emissions and so on. That can be counted. That can be counted. So in my view,
the social part, I guess, is more difficult because it's more, let's say.
But at least you can start. You can start to discuss and so on. And if I can already respond a bit before to give the word to the others, also to the second question, because it takes immediately. My view has been the following. Let's put the research in front. At least we agree on some basic principles. We can be wrong, obviously. We can easily be wrong, but at least we agree on some principles and use our common sense to see whether these indices are proper or not. I usually go to see for events and so on. What, on contrary, I find much more individual and difficult to say is when you move to individual basis to the firm, because that things obviously can be completely different depending on who you're talking. I don't think it's a generic statement that will function. Thank you.
Thank you. Thank you very much, Francesco. I don't know if Giorgos or Raffaella want to add anything on this, let's say, use of AI for sustainability measurement, in particular social and environmental. No, if not, we go. Yeah, please, Raffaella.
On this, I don't. If there is the other question instead on bias, for which I can say something based on at least our field, the field of NLP. And what I can say there is that indeed bias is a. Oh, do you want first to say the question?
If you want just briefly introduce it, yeah. So I think a couple of years ago we wrote a paper on the dark side of Industry 4.0, and I think now the big question is about the dark side of AI. So we talk about AI as a way to make entrepreneurship more sustainable, but the question of let's say Yorgos is whether, let's say, these technologies could also have some negative impacts on social and environmental sustainability. So the question here is
particularly,
for all the
Raffaella
speakers,
particularly mentioned something in one of her slides, and she presented,
Yeah, please go ahead, Raffaella.
So no, the connected with the question, there was somebody asking how can we make sure that these systems are not affected by the bias in the training data. So with respect of these, I can kind of say that there is a lot of work that we are doing in the NLP community to address this issue, mitigating the bias, and also making sure that the performance of the models is explained, so the model can explain why is generating the output is generating. And also we are looking at, so that the one I was saying on the evaluation, that it's an important aspect to take care of. We are also looking a lot inside the mechanism of these models to see why they are giving their answer, how they are functioning inside. So there are these two kind of research lines that are addressed in order to address the issues you are pointing at, how to mitigate the bias and explain the behavior of the model, both for the internally and externally. So there is work done in this direction.
Thank you, Raffaella. Yeah, I don't know if Giorgos or Francesco would like to add something on these, let's say, drawbacks.
I can only support what Raffaella said indeed on that element, and eventually any innovation we had in the past, we always had this problem. It was a very good example you gave with Industry 4.0. So I still believe that we learned something from the past that we can apply also in this case, and we can mitigate, maybe not completely remove, but mitigate some of these issues that we know bias is the easiest to think.
Thank you. Then we have a question for Raffaella from Andreas. And it's a very practical question. So if you know any platform where people can learn the basics of AI and try some application, so if you have any suggestion for person that would like to...
As I said, Hugging Face, it's there and it's not hard to use. They've really done a good job in making models accessible, but you cannot start from scratch. I mean, you do know have to know some Python scripting. Then, I mean, we have been running this Erasmus Mundus in this topic, LCT, for 20 years. And there we always provide teaching material, and we shared everything we produce for our program. So that can be something to start with. And usually also our teaching material is always online. So we have always, as a community, always made everything available. ACL is the association, by the way, and all our papers are open access.
Thank you, Raffaella, for the answer. And then we have a final comment by Madi Bastani, and it's about his own experience on the topic. So I try to very briefly summarize it. So he has a background in agricultural economics and has also worked in entrepreneurship and business development in rural areas. And he said that, let's say, the AI has very strong implication for agriculture and agribusiness in several parts of the processes, packaging and sorting, image processing, also to identify, let's say, products and product characteristics based on the different features. And also the use of satellite images, which we have not talked today too much, is also playing a very important role on this in order to, let's say, optimize in particular agricultural activities, as we are here as a ICA SIG forum. I think that is also a very, very important and interesting comment. And of course, this is allowing more to estimate the productivity, the yield rate, but also to propose new ideas and opportunities, also to leverage on the data that would be collected and to offer additional business model associated with that. Apart from that, I think we only have further comments about Manuela Guerra and also Francesco. Again, that just saying, so answering or commenting the introduction and the comments of previous attendees. I don't know if there are any final questions, any final comments. We just run out of time now. So I don't
Andreas
know if
has his hand on.
Yeah, so one final call maybe also to the participants and also to the speakers here. Do you have information about a platform that collects applications of AI in agriculture, in sustainable business, in somehow? So that would be great to see more examples. And if you have any of them, please post them in the chat. Also the participants, please. So we are really looking into understanding better how artificial intelligence and generative AI can be used for sustainability. So we are happy to get any information also on projects, on platforms that collect information, either in the chat, or you can also send us an email. I guess we can be found easily on the webpage of ICA and ICA EDU. Thank you very much.
Okay, thank you very much, everyone. And I guess if we don't have any more comments, and since we've passed 3 minutes, 3 o'clock, we will conclude here. I would first of all like to thank the 3 speakers for the valuable presentations, the valuable contribution into this discussion, and also for answering the questions. And of course, to thank the audience, the participants, for their questions and for sharing information. So thank you very much all, and we're looking forward to see you again in our next webinar. Thank you.
Thank you.
Thank you very much, and bye-bye.
Thank you. Thank you. Bye.